From ContainerDays Hamburg, this video is proudly presented by Dux IT.
Welcome everyone, and thank you for joining my session here at ContainerDays. Today we'll take a deep dive into Kyverno, specifically how to debug, test, and monitor policies. Many of you know already the basics of Kyverno, so this talk is not about simple pattern validation. Instead, I want to show some practical techniques that you can use, and I will demonstrate them in a live demo. But before we dive in, let me say a few words about KubeSpectra. KubeSpectra is a brand of Infologistix, which is a company I work for as a DevOps engineer. And our mission is to make Kubernetes easy and more secure for teams. So we work closely with projects like Kyverno to bring best practices into production environments. Here's what we'll cover today. We'll start with a short recap of Kyverno just to set the stage. Then we'll go step by step through an advanced validation policy with James path, deny rules, variables, and preconditions. Then we shift into debugging and testing, including both the command line interface and CI automation. And finally, we take a look into monitoring and reporting. So Kyverno is at its core a policy engine which integrates directly into Kubernetes. It manages policies as Kubernetes resources. And if we talk about the Kyverno policy, we essentially talk about a collection of rules. And each rules define when it should be applied through match clauses or exclude clauses, and what it should do. They can be applied cluster-wide or namespace-wide. And there are two enforcement modes, audit and enforce. In audit mode, violations are simply recorded, which is useful when rolling out new policies to see the impact. In enforce mode, violations actively block resource creation or modification. Here's an example of a simple policy that many of you might have seen before. It's straightforward. We match a pod, and then we have a validation block with a failure action audit and a message that says using immutable image tag latest is not allowed. And then we have a part with a pattern which is checked. So if the latest is found in image field, we will reject it. The key message here is not the policy itself, it's the structure with the match block and the validate block. And if you understand this structure, you can extend your policies to more complex use cases. And here we are, a new policy is needed, and the requirement says, ensure that namespaces have a project ID label that matches the expected project ID from a predefined project to namespace mapping, excluding the default namespace. And there is a short example what it looked like. We have a namespace with the name team X, and the project ID label would in this case be PID 12345. And as a prerequisite, of course, we need to know this mapping. And for the implementation, we need to find a way that the policy can also know the mapping between project IDs and namespaces. And next, we need to ensure that namespaces without or with incorrect project IDs should be rejected. And we need an exception for the default namespace. To achieve this kind of validation, we need to have some knowledge about James path. James path is pronounced James path, and a declarative query language for JSON, which give us a way to extract and filter exactly the piece of information we need. And you can find these expressions in many places in Kyverno, like in preconditions, deny rules, or for each loops. And without James path, we are limited to simple pattern validation, as we have seen before in the example of the deny latest tag policy. Some use cases for James path is to access labels, annotations, container images, or you can check whether the label app from a requested object equals to front end, or you can loop through arrays to get all the images from the init containers on containers in your deployment or stateful set. One more really nice feature is to embed these JamesPath expressions in a message field. If you might show, for example, what the actual namespace is in which the workload should be created in, that helps your users to understand why their resources were blocked, and it helps you to understand your JamesPath expression. Syntax-wise, double curly braces are needed whenever you embed the JamesPath expression. And if the field is only the expression, you need also quotes. And if it's mixed up with expression and text, the quotes are optional. And to access nested fields, you can use the dot operator like request.namespace. But what does request.namespace actually mean? If you take a look into your manifests, you won't find a property that's called request or request.namespace. So let's walk through the Kubernetes request to get a better understanding of it. Imagine we create a pod with kubectl1, and then the Kubernetes API server firstly validates the YAML file and then adds some default values like timestamps, and then it wraps the request into an admission review object and sends this admission review object to the admission controllers. And the admission controllers can be the built-in from Kubernetes or, for example, in our case, Kyverno. And inside this object are a lot of information like the origin resource, then the information about the operation type like create or delete, or you get information about the namespace in which the resource should be created in, then you get information about who triggered the request, and so on and so on. Here's a snippet from the admission review object from the pod we created on the last slide. And you see the property request is here, and it contains a namespace. So if you see again request.namespace, you know it refers to the admission review object to give you the answer from the actual request you sent. Next, Kyverno extends the standard filters from JamesPath with custom filters, which is very helpful in Kubernetes use cases. And here are two examples. The first one, the contains filter checks if a given subject contains a given search string. If you ask, for example, contains foo bar foo, the result is true. And the other example, the pattern match filter, is a bit more powerful. Here you can give an input pattern and compare it to a string or value. And the output also is a Boolean. And at this place, the command line interface from Kyverno comes into play. It lets you test and validate your policies locally. So without having to continuously deploy your policies to a cluster. And a particularly useful subcommand is JP, which enables you to experiment a bit with JamesPath expressions. For example, you can grab a pod manifest in JSON and run queries against it to see if it returns a value that you expect, or you can load JSON files to check your queries against it. Now let's go back to our namespace policy and find out which JamesPath expression we need to fulfill the requirement. Following the description, we need to pull out the label project ID and the name of the namespace. And I prepared some command. Here you see I get a namespace called teamx, and then I want to get with the JP query, the metadata labels, and project ID. And you see when I search for this path, I get project ID label, which seems to be good for our use case. And you could do the same with metadata.name. So this JamesPath expression might be the ones that we will need for our policy. We have, of course, request objects, since we refer to the admission review object, and then we want to have the project ID and the name. To get more powerful Kyverno policies, it makes sense to make them dynamic by using variables. And there are some predefined variables in Kyverno, like the one for the service account, or you can maybe reuse values from anywhere in your policy with dollar parentheses and path. It's similar to a relative path, but more importantly for our use case is the last bullet point, that you can include data from config maps, from Kubernetes API server calls, from other cluster services, or even from image registries. And those values are then available as a variable in your policy logic. For a config map, for example, you have to define a context block and load the config map, and then you can reference it from inside your policy with the James path expression that includes the context name, then data, and the keys you've given in the data. Back to our policy that we want to implement, we have a config map that contains our project to namespace mapping, and you see in data we have a PID 12345 with the value team X, and the same for team Y. That is the one we want to include into our policy, and this is the context block we should include in our policy. We define the variable project map, and then we load into it the config map from the left side with the name project namespace mapping. Now we come to the heart of our policy, a deny rule. Deny rules are more expressive than pattern validation, and the idea is simple. If the condition in the deny block evaluates to true, the request or the resource is blocked. And inside the deny block, you have to choose between all and any. All means that all conditions must be true, and means at least one condition must be true. Then you define a key, usually a James path expression. You pick an operator like equals, not equals. You can pick from a lot of operators, and you provide a value to compare against. And if that condition evaluates to true, the request is blocked, and the message you've written will be displayed to the user. The key difference from pattern validation here is that you can explicitly say what is not allowed. And this is sometimes more intuitive, since you can say deny if label is missing. Again, back to our policy, we need a deny rule for this, and we have two conditions. If one of these two conditions is true, we will block the request, and the first condition checks if a namespace contains a label project ID. For this, we have in the key the check if the project ID is empty or if it's existing, and if it's not existing, we will block it. And in the second condition, we use the filter pattern match, and as input pattern, we take our variable project map, and from the data, we grab project ID, so we get the team name, and this one we will compare with the name from the namespace. And if this equals to false, it evaluates to, the condition evaluates to true, and the request would be rejected. Otherwise, it's fine and the validation is passed. Finally, we come to preconditions. Preconditions allow us to add some exceptions. They act like filters you can insert, and they're evaluated after the match exclude clause, but before the actual rule body. And if the precondition evaluates to false, the rule body is skipped. You might need this, for example, if you want to run a rule only if a certain annotation is existent, or if you want to skip some validations for specific namespaces. Technically, preconditions are written like deny conditions, but instead of denying, they determine if a rule should even be executed. They can also include context data, so you can make decisions based on external information. And that is what we need to have the exception for the default namespace. We check if the metadata name is default. If it's default, the rule will be skipped. If it's not default, the rule should be executed. And now that we have seen all the blocks we need for our policy, we can put it together. before we start testing. Here we have the whole policy. We see here the match clause. We will match namespaces, then followed by the context block where we load our project map with a variable config maps. Then here we have the precondition to skip the default namespace. And at the end here are our deny conditions to check if the namespace is properly configured. Now, after finish writing our policy, we of course want to test it and to see if it worked like we would expect it. And for this, we can start with manually testing with the command line interface. It lets you test your policies against some resources locally. That means you define some resources that should be tested, and Kyverno test takes them and checks them against your policies. Per default, the command Kyverno test looks for a file Kyverno test YAML, and in this file are all your tests defined that would be executed. And as a result, you can choose from 4 options: pass, skip, fail, and warn. And if your test results your option that you have chosen, your test is passed, similar to unit tests when you code in Python, Java, whatever. Here's a snippet from the Kyverno test YAML we will use. You see we load at the property policies, the policy we have written, then there are some resources we want to test against. Then there are variables. We need an extra variable file because we load external data from a config map, and our tests need to know these data, so we give the variables with the variables file to the test. And under the property results, we have the test defined where we say which policy, which rule, what resource, and what is the result. And in this case, we have a namespace called team X, which is checked. Next, we can test, of course, automated, as there are 2 main use cases. And the first one is for development teams. They are usually responsible for their manifests. And if they update their manifest, they maybe want to check if they're still compliant with your Kyverno validation policies. So they can include their test in the pipelines. And if a test is failing, they know it will also fail while the deployment to the cluster. And the second use case is testing the rules, of course. You can test the behavior of maybe newly written policies, but you can also ensure that changes in your policies are still doing what they should do. Or you can test maybe new Kyverno versions to see the impact on your policies. For GitHub, there's a GitHub action you can easily use, and for this, you of course need a Git repository that contains the policies, the resources to be tested, and of course, the tests you would like to run. So let's change back to our policy. Here is the test command with Kyverno test. And I should show you the structure before. Here's the structure. There is a directory with the policies. Then here's the directory with the tests. Here's the Kyverno test YAML. Here are some resources we want to test. For example, here are 3 namespaces that don't contain the label project ID, or 1 namespace from team Y has the wrong project ID. And here are the variables. And then we can go back to the live demo where we see what the test results of our policies are. And we see all our tests failed with the message that's a bit helpful. It says not found. Okay, not found means we maybe have imported something, but it's missing. So let's take a look again to our policy where we have imported something. We have here the context block where we use the config map. Maybe there's something wrong. We call the variable project maps. Where do we use it? In line 37 here, but it's called only project maps. So this could be the mistake. So let's test it again. And we see we got again a failed policy, but this time with another message. We got a failed policy that should have passed, test, I mean, not policy, and we got a test result that should be failed but passed. So what does the message say? Namespace team X with project ID PID 12345 is not allowed, and the other one from team Y passed the test. So it sounds like quite opposite to that what we wanted to have in our condition. Let's take a look into our condition. We have here again our pattern match, and we have as input the project ID label from the config map, and we compare it, and if it, for example, evaluates to true, we say true not equals false, that is true. So the condition evaluates to true in the case that the label corresponds to the namespace name as we wanted. Maybe we should try not equals, we should try equals as an operator. And now we seem to have found all the mistakes, all 5 tests has passed. So let's push it to Git and see what the automatic test result will be. Oh, I forgot to have the no connection here. Okay, I prepared for this. Here's the GitHub action, which has already run after fixing the policy. And you see here what the action does. It installs the command line interface. Then in the next step, it checks the version you're using or you gave it. And here are the results from your test cases. And as expected, all results say pass, and the reason is okay, just like in the local case. So our tests are successful. Let's apply our policy. Okay, it's applied. And now, after we have created or applied our policy, we can take a look into the admission review object I mentioned earlier and create a new namespace, and then take a look into the logs and search for admission request, and I think it was backend, yes, and search for our namespace in the logs. If you want to see this admission review object in Kyverno, you have to enable the debug mode, which you can do by setting the flag dump payload to true. And here we get a lot of information. So I will copy this one, which is the part we need. And now we can analyze it a bit more. And this is a request part of the admission review object. It's not the whole object, but you get a lot of information like name, namespace, then what kind, the metadata, again the name, then the operation it was created, we created the namespace, and much more, which can be pretty helpful if you want to debug your James path expression, but don't know what fields you can use. Now that we have applied our policy and tested it, we want, of course, see the impact on the cluster of our policy. So we need some reports and maybe monitoring. And the easiest way to get the results is to ask for the policy report and take a look into it, and then you see as a result, in this case, that it has failed because I used the latest label, which is forbidden and should not be used. And if you have many namespaces with many workloads, you get a lot of policy reports distributed across all namespaces. The policy report is a namespace scoped resource. You can also have cluster reports that are cluster scoped. And if you have a lot of policies, your reports get longer and longer and longer, and it gets messy to find, for example, results about failed rules. And for this case, the policy reporter was developed. It makes the results of the Kyverno validations visible and observable. And for this, it provides a dashboard where you have a graphical overview of the scores from your validation policies. You can also create custom dashboards for special labels, namespaces, whatever you need. And you can have optional metrics endpoints to use the results in Grafana or Prometheus. Oh, that was much. So if we move back, we can take a look into the cluster policy report, which refers to our policy. And at first glance, we see here the default namespace is skipped just as we wish to. Then we have a lot of fails, and we have one passed validation for the namespace team X. And so that we can see more in policy reporter, I also applied the validation policy from the beginning that denies the latest image tag. So we can also see some policy reports, and that's quite a lot. And that's where the policy reporter comes into play. I installed it via Helm. And now we can take a look into it. Oh, I've opened it already. Okay. Here's the general dashboard. When you open it, you get, is it big enough? Okay. You get an overview of the results that you have, how many passed, skipped, or failed results there were. Here you get the results from your cluster scope policies, and we can confirm that there was one passed validation if we took a look into the cluster policy reports in our terminal. And here you can get more details about everything. Here are the namespace scoped things, and you can have another dashboard where you just get the counts for your policies, and here are 8 resources skipped, 3 have passed, and 3 have not passed, and here it's similar for the validate namespace project ID. This one is a custom dashboard for all namespaces that have the project ID PID 12345, and we get the policy report results only for these namespaces. And we can confirm team X was a valid namespace, but we also can see the namespace team Z. The reason is our policy is still in audit mode and not enforce mode, so it was possible for me to create this namespace. To summarize what we have seen, understanding James path and the knowledge about the admission review object can help you to understand your policies. Especially the admission review object was for me crucial to help me debug my policies, because I could see who was the creator of some resources. Then you can use the command line interface for testing and experimenting with your policies and expressions. And at the end, you can have a quick overview with a policy report about the results from your policies. And as you may think, many ways lead to Rome. Our policy can, of course, written differently, for example, without the pattern match, or you can move the precondition into the deny block, and so on. And I have shown only a subset of popular features we use from Kyverno, but Kyverno offers a lot of more features. And that is the power of Kyverno. Thank you for your attention.
The first question is what's the name of the awesome Markdown terminal add-on from Visual Studio Code?
It's called RunMe. You can have it as plugin in VS Code if you search in the marketplace.
Nice. I think the Wi-Fi is having struggles, but I have the questions here. How could you receive the admission review object?
If you're happy to get only the request part from the admission review object, you can do it with the debug mode in Kyverno. If you want to get the whole admission review object, I think you have to play with your control plane nodes. I haven't found a way yet to get it, but I would be interested in knowing it if somebody knows it.
When do you use Kyverno Chainsaw for testing compared to just Kyverno Test?
I have read about Kyverno Chainsaw. I haven't tested it yet, so I can't answer that correctly, but I think it's a nice tool. It should be tested, so maybe just test it out and see if it's fine for you or if you prefer Kyverno Test for your tests.
Okay, thank you. I don't know exactly what's going on right now, but I would invite everyone to join Marie offline and ask the questions there, if that's okay with you.
Mm-hmm. It's fine.
And then we just join the coffee break earlier. Yeah, thank you.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.